Okay, we are going to tackle electron configurations. Now, electron configurations are pretty important, and the reason why you stress them so much in chemistry is because this is a way for us to understand how the electrons within an element are located and how are they distributed evenly. So, for example, if we take boron right here, and boron has 5 electrons, right? Now, all 5 electrons aren't always located at the same spot. Some could be here, some could be here, some could be in the second orbital. So a better way to organize that is what chemists use, electron configurations. Now, your teacher may have gone over 4 different types of orbitals: S, P, D, and F. And these are orbitals that we're going to use to understand how the electrons are located. So, for example, when we took boron, some of the electrons could be in the S, some could be in the P, and I'm going to show you how to figure that out by using the periodic table. So first and foremost thing, I'm actually going to take this helium right here, and I'm going to place it right next to the hydrogen. And in a second, you're going to see why. Because the helium is actually in the S block, and it's within the s orbital. The only reason why the helium is here is because it actually has characteristics like the rest of the noble gases, like neon, argon, and krypton. But for simplicity's sake right now, we are not going to consider helium on this side. And trust me, it's going to be much easier when the helium is on here. So now I'm going to categorize my different blocks on the periodic table. Right here, which I have circled in red, is the S block. And right here, this whole chunk right here, on this side, is the P block. And as we keep going down, this whole blue area in the middle, this is the D block. And if we continue down, this area is the F block. Now, the electron configuration is pretty easy as long as you keep in order which row you are in. So let's start labeling our rows. This is the first row, second row, third row, fourth row, fifth row, sixth, and seventh. Now, the main idea is to basically count how many boxes till you get to the element that you want. So if we take carbon, for example, right here, let's note down that the carbon has 6 electrons. And we have to figure out how these 6 electrons are distributed within these orbitals. So let's always start with the first row right here. So for carbon, we're going to start with the first row, and we're in the s orbital, right? And how many boxes are in the first row within the s orbital? We have hydrogen and helium, so it's going to be 1s, 2, because there's 2 boxes, right? Now, since I got rid of the helium from over here and I put it over there, there's no 1p. So we're going to go then to the next row, which is going to be 2. And then again, s orbital comes first. There are 2 boxes, the lithium, beryllium, so it's going to be 2s2. And then we're going to go straight into the p block. But we're still in the second row, remember. So it's going to be 2p. And now we're going to figure out which column the carbon's in. And remember, this is the first column, second, third, fourth, fifth, and sixth. So carbon is clearly in the second column. So it's going to be 2p2. Whoops, right here. Now, a great way to double check that you did it correctly is by, remember when I said that carbon has 6 electrons? Make sure all these subscripts add up to 6, which they do, right? 2 plus 2 is 4, plus 2 is 6 electrons. And hence, you have the correct configuration for carbon. Now let's try another example to better understand. So instead of carbon, let's pick one a little bit more down the line. For example, let's try sulfur right here. Now sulfur has 16 electrons, so let's note that. So we're going to do the same thing that we did for carbon. And we always start off with the first period, right? So again, 1s2, because there's 2 blocks. Then we get to the second row. And again, it's going to be 2s2, because there's 2 blocks. And remember, we have to go through all the blocks till we reach sulfur. So it's going to be the whole 2p6, and then we're going to reach the third column, the third row, which is going to be 3s, how many blocks? 2, 3s2, and then we're going to reach the third p block, and which column is sulfur in? 1, 2, 3, 4. Sulfur is in the fourth column, so it's going to be 1s2, 2s2, 2p6, 3s2, 3p4. Again, always try to double check to make sure they add up to the number of electrons. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 4 is 16. Hence, you have found the correct configuration for sulfur. Now, let's take it up a notch and start understanding how to plug in the d orbitals. So the d orbitals can get tricky, and that's where people get really confused, because you have one little twist. Let's note down the row numbers as n. So you know how we have used the same row number for the S and P, but now when we get to the D, it's actually going to be 1 minus the row number. So for example, when we're in the fourth row, even though it's going to be 4s, right, it's going to be 3d instead, and then 4p again.